Statistics, Chapter 6, and I'm doing problem number 10, which is on car speeds. I'm going to do 10, 12, and 14, which are all on car speeds, get progressively a little bit more complex. So it says, John Beal of Stanford, California, recorded the speeds of cars driving past his house, where the speed limit read 20 miles per hour. Let's just write that down. Speed limit 20 mph. The mean of 100 readings was 23.84. So our mean, well, actually it's not mu, that's the model symbol. Our mean, our y bar, was 23.84. With a standard deviation, so our standard deviation was 3.56. So I am dealing now with an n, 23.84, comma, 3.56. That is my model. That is the model that I'm dealing with. So I'm being asked two questions on this one here. The first one is, how many standard deviations from the mean would a car going under the speed limit be? So let's follow rule number 1, which is make a picture, make a picture, make a picture. Here is my normal model. Here is my mean. My mean is 23.84. And I know I have standard deviations, 1, 2, 3, 1, 2, 3. Well, this is a little bit hard for me to do here, so let's use the calculator. If I have a mean of 23.84, and I subtract one standard deviation of 3.56, so my first spot here is going to be 20.28. That is my first standard deviation, negative. If I subtract again, negative 3.56, it doesn't work because that's dependent on my hand. So let's erase that. See if it works now. Negative 3.56. My next standard deviation lower is going to be 16.72. Let's again subtract 3.56. My third standard deviation is 13.16. Well, we may as well go positive too. So my mean is 23.84. I'm going to add 3.56. So my first standard deviation above the mean is 27.4. I add 3.56 again as my standard deviation. I'm going to get my next standard deviation is 30.96. And then my third standard deviation above the mean plus 3.56. 34.52. 34.52. So I've kind of got a little picture now of my model. And the question they're asking me again, how many standard deviations from the mean would a car going under the speed limit be? Well, the speed limit is 20 miles an hour. I can see from my diagram here, please go away. I can see from my diagram here that 20 miles an hour is going to fall somewhere like right over here. It's going to be more than one standard deviation, because one standard deviation negative is going to take me to 20.28. 20 miles an hour is less than 20.28. So how do I go about calculating this to be exact? A z-score is what we use to measure the number of standard deviations away from the mean a particular data value is. So I would use my formula, z equals y minus y bar over s. And in this case, my y is 20 miles an hour minus my mean, 23.84, over my standard deviation, 3.56, That equals, let's go over to the calculator. So I'm going to go 20 minus 23.84. And then I'm going to divide that by 3.56. And I get that my z-score is minus negative about 1.08. That is how many standard deviations, 1.08 standard deviations below the mean, the speed limit is. The next part of this question asks, which would be more unusual? A car traveling 34 miles per hour or one going 10 miles per hour? So when we're talking about more unusual, we're saying which one of those cars is farthest away from the usual, which is farthest away from the average, which is farthest away from the mean. And we can measure that doing z-scores. So how are we going to do that? Let's see. I have, well, let's actually copy this here, just so I can see it more clearly. I have my n. I'm going to copy that. Let's bring it down here and paste it. Okay, here's my normal model. So those are the numbers that I'm working with. Separate our last part of the problem. And first thing I want to do is I want to say, well, which is more unusual? A car traveling 34 miles per hour. So what's the z-score for that? Z equals y, 34 minus 23.84 divided by 3.56. This is for my 34 mile an hour automobile. So let's do the math. 34 minus 23.84, that's my mean. 10.16, and I'm going to divide that by 3.56. So a car going 34 miles per hour is 2.85. That's a positive 2.85. Z-scores above the mean. What about a car going 10 miles an hour? Well, 10 miles an hour, Z equals 10 minus 23.84. So again, I'm going to the Z is equal to Y minus Y bar over S. So all this is over 3.56. Let's go over to our calculator. I have 10 minus 23.84 divided by 3.56. That is a z-score of negative 3.89. Well, it seems to me as if our car going 10 miles per hour is much farther away from the mean than our car going 34 miles per hour. So I would say that that is the unusual one, is a 10 mile per hour, because its z-score is so much further away from the mean.